I hope all is well. So we have an O-level past paper question from the year 2020. The session is May-June. This is question number 3. We'll discuss trigonometry and how to find the angle of elevation. I have it in front of me. Let's start. So the question reads, a light L is fixed on a building 8 meters above the base B of the building. Now, then they've given you a diagram which is not to scale. A point P on the horizontal ground 12 meters from B. Okay. This is what they're talking about, this point P. Calculate the angle of elevation of L from P. So the angle of elevation of this point would be right there. This is what we are looking for. Okay, in order to find that, we need to use a trigonometric ratio. In this case, we have the opposite and we have the adjacent. So we use tan theta. Okay, next the opposite is of course 8 divided by 12, and tan theta is what we are looking for. So when we plug this into our calculators, we divide 8 by 12, okay, and then we do tan inverse of that ratio, we get 33.7. So your theta in this case is 33.7 degrees. You write it over there. The next part says that a ladder is placed on the ground at Q to reach the light L. This is another diagram. It's not the same as the first one, and it is not to scale, drawn not to scale. The ladder makes an angle of 70 degrees with the ground. Calculate QL. They've asked you to find this length. Now, the trigonometric ratio that we use in this case is opposite upon hypotenuse, because the hypotenuse length is the one in front of the 90-degree angle, and the trigonometric ratio that we use is of sine theta. They've given you theta. So you use sine theta equals 8 over QL. Then the next step is you write QL equals 8 divided by sine 70, and the length of QL, let's do that, 8 divided by sine 70 comes out to be 8.51 centimeters. So 8.51 meters. So you write the length there. Okay, let's move on. They've given you another diagram and it's still not to scale. A vertical pole RS of length 1.6 meters is placed touching the horizontal ground. The light produces a shadow TS of the pole on the horizontal ground. LRT is a straight line and TB is 6.5 meters. Calculate TS. They've asked you to find this length. First, in order to find this length, you would need to know this angle right here. We can find this angle by using LBT as the larger triangle. So, in this case, we do opposite upon adjacent, which is equal to tan theta. First, we need to find the angle, only then we would be able to find the length of TS. So, the opposite in this case is 8. We're trying to find the angle using the larger triangle. It's 8 and the adjacent is 6.5, and you do tan theta, then you do tan inverse, so theta comes out to be 8 divided by 6.5, and then tan inverse of that ratio, you get 50.9 degrees. So this angle right here is 50.9 degrees. Now of course you need to find the length of TS. That means you would be using RST, that triangle, and the trigonometric ratio for that triangle to find the length. So we do opposite once again upon adjacent equals tan 50.9 in this question, and opposite is 1.6, and adjacent is the length we are looking for, which is TS right over there. So we write TS over here, and it is being used for tan 50.9. So I switch them, sorry, and TS would be equal to 1.6 divided by tan 50.9, which gives me 1.6 divided by tan 50.9. It gives me 1.3 meters. That is your answer. I hope all of it made sense. The complete working of the question is of course present in the description below for you to download. If you like the video, hit the subscribe button, and thank you for watching.